Okay, so more physiology and histology. Acidosis. So if CO2 increases too much in the arteries, then you get acidosis, respiratory acidosis. Because uh, it forms carbonic acid with the water in your blood. And yeah, that's weird. There's also the Herring-Brewer reflex, which thank you, Dino. I appreciate that. There's the Herring-Brewer reflex, which are stretch receptors near the lungs, or all around the lungs. I don't know. It's where, as your lung expands, there's afferent activity which increases, and it tries to override inspiratory stimulus. So, like, you feel whenever you inhale, there's a certain point when you're like, oh, okay, my lungs are full. And that's when you exhale, you know. But there's an opposite reflex which will increase inspiratory efforts if the lung is not allowed to completely deflate. If you don't exhale all the way, that point where you exhale becomes the new point. So, like, if I were to go, and I'm holding air, there's also a reflex that says, oh, you need to let out some of that air, get your lungs back to normal. And it's also, I bet it has to do with the pressure as well, the pressure gradient. Yep, diaphragm, stretch receptors, too much energy being exerted. Is there a way to make my lungs work better? What problems are you experiencing with your lungs? Primary drive is linked to arterial CO2 in those receptor signals. The relationship of CO2 and ventilation is linear and normally pretty steep. When you sing a song you can't sing as much, are they shrinking? I don't I don't know. I don't think so. I would say maybe like are you talking about you can't sing as much because you're getting tired, or you're just not able to sing for like an extended, okay, out of breath? It might be that you are just not taking big enough breaths before singing certain notes. Maybe that's what it is. Like, you have to take a big breath, I think. Ronaldo, is that you? No, I'm not Ronaldo. Um, September flu gang. Oh, you have the flu? I'm sorry to hear that. Um, anyway, that slope, the CO2 and ventilation difference slope, it gets even steeper with hypoxia. Hypoxia is the tissues don't have enough oxygen. Hypoxemia is your blood doesn't have enough oxygen. Pacemakers. Fires faster. 6 BPM. Whoa. Secondary drive due to arterial O2. Asymptotic. What? Displaced to the right. So what is hypercapnia? Hypercapnia is too much CO2 in the arteries, I think. Yeah, high CO2. It's not the gases that increase heart rate, because sometimes your heart rate increases before exercise even starts. It's nerves in the muscles that detect pH and temperature. When you exercise too hard and feel the burn, for example, that's the nerves. The nerves are telling you, oh man, I'm exercising. And that's it. Wow, that was short. Okay. Now we're going to do nutrition. Man, maybe I'll knock out all these pretty quick. Then I can get back to studying anatomy. Fun. What am I on? 19th? Yeah, 19th. Okay. Equine nutrition. Horses. I don't know if any of you guys have horses, but maybe this will help. There's something called a body condition score. We've talked about that in previous videos. And then there's a cresty, not crusty, but cresty neck score. So horses are herbivores. They eat cellulose, they eat plants, grass, right? Cellulose is the most important structural material of plants. It's the main energy source of herbivores, and it requires microbial digestion. Those microbes are symbiotic microorganisms found in either the rumen and ruminants, or in the case of the horse, they're found in the cecum, which is attached to the large intestine, so they're also found in the large intestine. Horses are hindgut fermenters. Lots of carbs can cause trouble because they get absorbed before they get to the hindgut. Same in us. If we eat lots of carbs, we have health problems. Obesity, type 2 diabetes, insulin resistance, all that stuff. Horses have small stomachs. They're basically eating 24/7. They will eat like 12 hours a day total, if they're allowed to. They don't fast for more than 3 to 4 hours voluntarily. If they if they're allowed to, they will eat pretty much all throughout the day. I've never seen a fat horse. Yeah, yeah. Horses, when they get fat, it actually doesn't really look like they're fat. Very interesting, and I'll get to that eventually in here as well. Very interesting phenomenon. You can kind of tell they're overweight though in body condition, because you start to see less of their musculature. It all just kind of starts to blend together. Hey, how's it going? That is a fat horse. Horses, because they've got such long legs, their bellies aren't ever going to really drag the floor or anything. Yeah, I don't know. I'll probably get to that here in a minute. So you can't really put a horse in bubble wrap, you can't just keep it in the stall all day. It's going to get bored. It's going to start chewing on the fence or whatever. These are working animals. They are monogastric, though. They've only got one stomach. So the protein, they get first access to any protein they get, and then the microbes get access to what they don't digest. Acid, and horses can get, they have a lot of stomach problems. They can have a lot of stomach problems. Let's see here. Yeah, the small intestine is enzymatic digestion. The large intestine is microbial digestion. They need water, fiber, protein, energy. They need minerals like calcium, phosphorus, and trace minerals. Snow is not an appropriate water source, just so y'all know. Roughage, concentrate. Yeah, high performance horses are going to need more energy. Pasture pets are going to be fine on just grass. You can just, if you have a horse and you have pasture, just feed it grass. It's going to live, you know? I mean, how did these horses live in the wild? They literally just ate the grass. That's it. They didn't get no buckets of oats. They didn't get supplements. They didn't need any of that stuff. And they still don't unless you're getting them to do what they don't normally do. It's important to look at whether supplements are evidence-based or not. Some supplements don't have any evidence behind them. Some do. Supplements don't need to prove their claims like pharmaceuticals do. So it can be risky sometimes getting supplements. I look like Felix from Stray Kids. I don't know who that is, but thank you. Thanks for the compliment, I guess. Mature horses consume an average of 1.5 to 2% of their body weight in feed per day. A horse with clover allergies, not so great. I didn't know that. That's interesting. That makes, I mean, yeah, because there's probably a lot of clover in the grass they eat. Wonder how common that is. And obviously, if a horse is growing or pregnant or it's lactating, it needs more energy. Or if the weather's cold. And you got to feed on weight, not volume. Some people say, oh, I give my horse a scoop of feed. How much is a scoop? What are you using for a scoop? Are you using a 5-gallon bucket? Or are you using an Eskimo Joe's cup? Or are you using, you know, it varies, right? Protein. Yep, horses need protein, but they don't need as much protein as carnivores do. And then roughage usually has adequate protein. And then there's websites that give nutritional requirements. Mostly their diet is composed of fiber, though, which is roughage. It's considered roughage. Can have concentrate. If you want to feed them oats, just be careful, you know. They're not really, their physiology isn't built for eating tons of carbs in a short amount of time. Because when are they ever eating? Okay, if you've got a horse grazing an oat field, how much of those stalks of oats are actually oats, and how much of it is stem, leaf, you know, that sort of thing. Quality of hay. The nutritional value of hay depends on many factors like the species, the growing conditions, the soil. The soil conditions, the maturity of the hay, the moisture content. And you can choose good hay. You can get hay samples and test those samples. You want to choose hay that's soft, leafy, green, and aromatic. You know, freshly chopped grass. Think about that. Like freshly chopped grass in the summer. Or freshly mown lawn. You know what I mean? Stuff like that. That's the kind of grass that horses would like to eat. But you just got to be careful if you're feeding horses with a round bale. They tend to be more dusty. And horses can overeat sometimes. If it's hay, you know, because they'll just eat all the time, right? But another thing horses can do in a round bale is they'll eat a tunnel out of it. It's pretty funny. I've got a picture here I can't really show because it's not my source, but anyway. You can also feed hay cubes, hay pellets, silage, haylage, and then you can feed complete rations. All of them have benefits and all have cons. All have benefits and detriments, basically, is what I'm saying. Pros and cons. There's supplemental feeds, supplement grains, if you're feeding like a performance horse, oils, if you need a performance horse that needs more energy, bran, minerals, etc., etc. Just be careful, Do your research before you feed a horse a certain feed. That's the gist of it. Some minerals horses will die if they eat too much of. Some they'll die if they don't get enough of. You just got to be careful with everything. Everything you feed horses. The easiest thing to feed a horse is grass. You just get it to graze on a pasture. Very, very low maintenance. Okay. That's it for nutrition. Now, back to anatomy. Vertebrae and back muscles. So there's the axial skeleton. This contains the skull, vertebrae, ribs, and sternum. There are 7 cervical vertebrae, 13 thoracic vertebrae, 7 lumbar vertebrae, 3 sacral vertebrae, and then there's 20 caudal vertebrae. Around 20. It can vary. 7, 13, 7, 3, 20. CTLSCD. CTLSCD. I have to memorize this. That's why I'm spending time on this. 7, 13, 7, 3, 20. CTLSCD. Yep. Okay. Okay, a vertebrae has a body, it has an arch, it has processes like the spinous process, the transverse processes, or processes, I don't know how you say that. Then it's got usually a foramen for the spinal cord to pass through. Okay, the first cervical vertebrae, C1. I can actually show you guys that. I've got a bag here. Okay, this is a cat vertebrae. Ooh, okay, all right. So these are the, oh wow, this is broken. This one's, is it? No, I don't think so. Just looks a little different. Okay, this is the atlas. Think about, describe it in the terms of the earth, okay? The earth is the atlas, because next we have the axis. The earth sits on the axis. The atlas sits on the axis. Okay, in the atlas, I really need to do this, y'all. This is really helpful for me. So give me a second here. I need to get out all the stuff I need to know. Wait a minute. Vertebrae. Do I have a human? Do I have human vertebrae? No. No, I don't. The only reason I've got these cat vertebrae here is because I'm in vet school. And we had to grab them from the lab. Okay. Let me find here. Vertebrae. Okay. So, of typical vertebrae, again, we might see this better on these other vertebrae down here. Yes, this is the, wait, is that the 7th cervical vertebrae? I don't know. Anyway, so every vertebrae has a body which is located ventral to the canal for the spinal cord. So look at this vertebrae, for example. This is probably thoracic vertebrae. Yeah, I would say so. See that they hook together, kind of. But anyway, we've got the body, which is this chunk of bone on the bottom here. This thick, bony part on the bottom here. That's the body. That's the vertebral body. They are set. So the vertebrae are separated from the body of the vertebrae. Wait. The spinal cord separated from the body of the vertebrae, cranial and caudal to it, by intervertebral discs, which are shock-absorbing fibrocartilaginous discs. So cranial, which is toward the head, and caudal, which is toward the tail, there are intervertebral discs in between every vertebrae that act as cushioning. Okay, the vertebral arch. Where's that? Okay, that's this top part. So you know how this thick bottom part is the body? This thick bottom part is the body. This top part is the arch, vertebral arch. Vertebral body, vertebral arch. Next, we have the vertebral foramen. The lateral and dorsal. So the vertebral foramen is literally, that's the part the spinal cord passes through. That's the hole, right? Together, the vertebral foramina of all the vertebrae form the vertebral canal, which contains the spinal cord. So if we were to stretch all these together, and we've got a cord going through them anyway, this rope here. If we were to, put all these together, that's the vertebral canal, the thing that this rope is going through. Okay. Intervertebral foramina. Hold on. Intervertebral foramina. I think it just depends. Anyway, let's... Cranial and caudal articular processes. Spinous process. Usually the spinous process is the thing poking out of the top. Atlas does not have one. Axis does. It's this thing right here, I think. Let's see. Yep, that's it. And these side things are transverse processes. The atlanto-occipital joint is the joint between the atlas and the skull. It's the yes joint. It's the joint that allows you to do this. Right? Okay, the atlas. We have the wings of the atlas. This is pretty easy, right? It's these things. The atlanto-occipital joint, I just said, that's where the skull meets the atlas. The caudal articular facet. it says it articulates caudally with the axis to form the atlantoaxial joint. Okay. Besides the large vertebral foramen, the atlas has 6 other foramina or notches. Wow. The transverse foramina are located in the caudal portion of the dorsal surface. Caudal portion. So that's towards the back. These tiny little holes, I think, are the transverse foramina. They extend to the ventral surface. Then we have the lateral vertebral foramina. Lateral vertebral foramina, transverse foramina. Okay, now on to the axis. It has a big spinous process. Right, it's always, the spinous process is always the thing coming out of the top. Cranially, the body of the axis bears a long pointed process called the dens. This thing right here is the dens. It articulates cranially with the dorsal surface of the ventral arch of the atlas, where it is held down by a ligament. Right, so that's where the axis, or that's where the atlas sits on the axis. Okay, the transverse foramen. The transverse foramen are still these holes in the side here. See those? Those dinky little holes? Tiny. They transmit the vertebral arteries, veins, and nerves. Okay, sorry about that. Okay. Where was I? Yeah, transverse foramen are those holes where the vertebral arteries, veins, and nerves pass through. Then there are 5 cervical vertebrae after that. 1, 2, 3, 4. And these are the wrong way, actually. Turn them around here. Huh. That first one has a strange spinous process. It is unlike the other 4. Okay. Hello, how you doing? I'm just going over anatomy right now. Okay. These are the remaining. So C7 does not have transverse foramina. Why? Because, well, actually it does on here, but, well, 1, 2, 3, 4, 5, 6. There, it seems like we're missing one here. That is strange. Oh, wait. No, it's just, it almost looks like a lumbar vertebrae, or thoracic. I'm doing okay. How about you? This is a little confusing, but yeah, this does not have transverse foramina. And it looks like the transverse foramina stop after that. I don't see any others. Oh, so those are only in the first 6 cervical vertebrae. That's good to know. Oh wait, I already asked you how you're doing. I'm sorry. I'm doing okay. My channel, well, pretty much my channel, I just record whatever I feel like posting, but right now I'm doing a series, I guess, where I'm studying for vet school. And so anyone who wants to watch, they're welcome to. Maybe they'll learn something, but why am I doing this? I'm doing this to mainly to teach my phone, if that makes sense. But I'm teaching other people in the process. But whether or not anyone's watching, I'm teaching, and that teaching is helping me learn, helping me study. So that's why I'm doing it. Doing this right now, at least. DINS, spinous process, transverse foramina, vertebral foramina, wings, body, arch. Yeah. Okay, then there's the thoracic vertebrae. 1, 2, 3, 4, 5, 6, 7. These are the thoracic vertebrae. They look a little different. Awesome. I'm glad you're learning stuff. Okay. Transverse processes. Okay. Thoracic vertebrae. There are 13 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wow. These sure get smaller though. Maybe it's, is it 7 instead? What was it? 7, 3, no, 7, 13, 7, 3, 20. So there's 7 7 cervical vertebrae, 13 thoracic vertebrae. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I guess. Oh yeah, they just, the process gets a little different. What? Hold on. Seven, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's it right there, 13. And then the difference between that and the lumbar vertebrae is that the lumbar vertebrae have much larger transverse processes. Sorry about that. Yep, there's always one troll. Anyway, okay. Thoracic vertebrae. They have cranial and costal foveae. T1 through T10. articular facets for the ribs. Oh, you did? Thank you. I appreciate that. Thank you very much. Uh, 7. Okay. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What am I missing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is... Okay. Cranial and caudal costal foveae. The caudal and cranial costal fovea of adjacent vertebrae together form the facet which articulates with the head of a rib. Oh, maybe it's that transverse process looking thing. Strange. Yeah, that's what I would say it is. Yeah. And that's where the ribs connect. Okay. Interesting. Caudal to T10. And you've got a bone to pick with me? That's fun. Can you get mod? I don't know. Let's see. Manage blocked words and change chat modes. Okay, as long as you don't as long as you don't abuse it, right? Don't abuse it. So you can review and remove chat messages and hide or put users in timeout. Okay, you're now a standard moderator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What am I doing wrong? Okay, okay, that was it. That was it for the thoracic vertebrae. This is 10, 11, 12, 13. Okay. Now, these are lumbar vertebrae. Lumbar. Okay, lumbar vertebrae. They have well-developed transverse processes. These things on the side, these are transverse processes. Hemivertebrae are vertebrae that have either fused or incompletely formed. This congenital defect more often occurs in brachycephalic breeds. The sacrum. Well, let's count all these lumbar first, because I guess that's all there is to know about lumbar. They're pretty much all the same. They've got an arch, they've got a body, they've got spinous processes, they've got transverse processes. That's pretty much it. 1, 2, 3, 4, 5, 6, 7. That's it. Then we have the sacrum, which are 3 Oh, yeah, that's okay. Thank you for Thank you for telling me about that whatchamacallit, troll, by the way. Now, if there's someone in the future who's a troll, I guess you can take care of them. So anyway, this is the sacrum right here. Usually these three bones are fused, but this time these two are fused and this one is not. Okay, the dorsal surface, which is the top, has three rudimentary spinous processes fused together to form the median sacral crest. There are two dorsal sacral foramina where? On each side of the crest. Yeah, I don't know. I'm not seeing them. Maybe they're not in cats. Yeah, I've got this book right next to me that I can't, well, unfortunately, I can't, well, I mean, I can share a little bit of it, but I guess, because, yeah, that's the source. It wouldn't be plagiarism. Okay, I'm going to go ahead and make Dino and KI also mods, because they were on my stream earlier, and they're pretty cool guys. Just in case a griefer joins, or a troll, whatever. I don't know. I don't know what these... The dorsal sacral foramina. Where are those? Are those supposed to be those holes? There's like... it's so hard to see. It's just so blurry, but yeah, these are small vertebrae anyway. If you don't want to be, just let me know. I can take it away, but anyway. I'm not seeing any foramen or foramina in any of these. A foramen, by the way, is a hole, basically. It's just a hole something passes through, like a vein, an artery, a nerve. Not seeing any. Okay, well, there's supposed to be two dorsal sacral foramina on each side of the crest. And that means 4 in total. I don't see a single one. The ventral surface has a cranial ridge called the promontory, and it has 4 pelvic sacral foramina. I also don't see any of those. I am grateful to be given a role as Divine Asmod. I promise to do my best. It's not that big of a deal, but you're welcome, man. It's not divine. It's just you're a cool fella, and yeah, I don't know. You don't have to if you don't want to, but yeah, you're welcome to. You're welcome to. So if someone's being annoying, you can either put them in timeout, or you can hide the user on the channel, which is what I've been doing so far. I've just been hiding the people who are, you know, being annoying. Anyway, you're welcome, man. Atlanto-occipital joint. Let me see if I can find a picture of these sacral vertebrae, because I am not seeing that anywhere else. Abnormal movement in the neck, compression of the spinal cord, atlantoaxial instability. How long have I been? Wow, I've been studying for 3 hours already. Studying. Sometimes I've been just talking to y'all, which is not, I mean, it's not a bad thing. It's just, I do need to study. I'm mostly offline or act viewer. That's okay. If you, I mean, if you want me to take away your mod, just let me know. Just yes or no, and then I can. But I mean, also if you're in the chat and you see someone spamming bad words or whatever, then just let me know. Or I mean, you can also just hide them from the channel or put them in timeout. Your choice. And got to be careful hiding them from the channel though, because I mean, here's the thing. If they come onto the channel just to spam, probably hide them, because there's a chance they're going to do it again, right? But no, you're awesome, Dino Hunter. You're awesome. But what was I saying? I don't know. Yeah. Okay. Atlantoaxial cervical vertebrae. Transverse process. Caudal articulation. I don't think I need to know that. Do I like nachos? I do. I don't eat them often since, remember, I'm carnivore, right? I try to eat just meat, eggs, dairy. I try to avoid plant products and carbohydrates, but I do like nachos. I've thought recently, I've been like, man, yeah, I could go for some nachos. No fruit. No, I don't really eat fruit. I do like fruit. I mean, sure, it's sweet and stuff, but no, I don't eat fruit or anything. I just eat normally on a normal diet. Like my normal diet is I just eat meat, eggs, it's dairy. I don't really drink milk because milk has a lot of sugar. But I could drink milk if I wanted to, I guess. I've got videos on that, on the carnivore diet, and on my channel, if you guys want to watch them. But yeah, I just kind of I explain a little bit more about it. I could make a live stream all about it if you guys want me to, but I'll have to like make a poll or something for that. Because right now I am trying to study anatomy. Want to know a funny story? Yes, I do. Yes, I do. Thank you, Dreamland. I appreciate that. Thank you. Yeah, got low subs. I'm not worried too much about it though. A lot of people have been subscribing recently, probably because of these live streams. Yeah, bread is also plant-based. Because it's usually made from wheat, sometimes other oats like or other grains like corn. You know, you've probably heard of cornbread, uh, rye bread, barley, that sort of thing. My mom bought me a 3-pound bag of oranges, and when I took it to my room, not even 1 hour later, when I weighed it. It was 1 pound. Wow. So you ate 2 pounds of oranges. All right. Well, fruit is definitely a lot healthier than a lot of other stuff. So that's pretty cool, man. Yeah, I can eat a lot too. Yeah, I used to love oranges as well. You just got to be like if in the long here's the thing. This the one of the reasons I don't eat fruit. In the long run, oranges, for example, they're very acidic, and so they can have an effect on your teeth, possibly. They're very sweet, contain a lot of sugar, but the fiber kind of cancels it out. But both sugar and fiber aren't really essential anyway. A lot of people say fiber, oh, you need your fiber. Well, why? Why do we need fiber? Well, if you eat a high carb diet, it it kind of slows the blood sugar spike, right? But what else does it do? Well, it doesn't digest in your digestive system. That's how it slows the blood sugar spike because it blocks the absorption of other sugar. It just adds bulk to your stool. And so for people with hemorrhoids, people with IBS, fiber can be harmful. And it just blocks nutrient absorption. So if you're trying to get the most out of the food you're eating, you know, I like fruit juice. I do too. I mean, I like the flavor. I don't much like it so much anymore though, because I just don't have it as often. But it's got a lot of sugar and it doesn't have as much of that fiber. So if you were to drink fruit juice, um, like if you're type 2 diabetic, for example, then your blood sugar would have quite a spike. Now it can be a good treatment for people who are having a low blood sugar attack, I guess, and type 1 diabetes. But that's because it's got a lot of sugar. Thank you. Thank you, Dreamland. I appreciate that. Thank you. How many cherries did you have at the same time, Dino? How many? Can I say the name Yashu? Who's Yashu? Oh, wow. Yeah, I've eaten a lot of cherries before too. My dad loves cherries. He used to buy them, and when I was younger, when I was younger, I didn't do the carnivore diet, obviously. I just did seafood diet. Everything I saw, I'd eat, you know. I see food and I eat it, right? That's what the seafood diet is. Yashu, that's awesome. Well, Yashu, you're awesome, and hope you have a great day. And you too, Adya. I hope I said that right. So, yeah, when I see food, I eat it. That's the funny part. It's like a pun, seafood diet, but it's actually seafood, like see with your eyes. Where am I from? I'm from Oklahoma. Right now I'm in Stillwater. I am at Oklahoma State University studying vet school. So, okay, let's see here. Lumbar vertebrae. Did I see your comment? Is it the one that says local stay, or was there one before that? I saw the one before that. I really appreciated that. Yeah, it said, It was the one about live streaming. Yeah, I won't give up. I'm gonna keep doing this as long as I'm in vet school, at least. And then probably after that, I'll do like one a day, I think. So. In dogs and cats, there's 7 lumbar vertebrae. And I won't forget you when I get famous. I'll try. Well, okay. I don't want to. I can't promise anything, and I don't even know if I want to get famous. I don't know if that's a good idea, because then people are going to be like, I don't know. I'm just going to have a lot less private time, I guess. I don't know. I don't know how all that works, but I'll try not to, because I'm already famous. Um, yeah, I've heard of Undertale. I when I was younger, I watched a couple YouTubers play through it. That was a pretty cool game. Ow. Let's see here. I don't know if I saw that message that you told me your name. I'm sorry. Let me see if I can find it. No, I don't. Oh, Tina. I think I may have seen it. I feel like I saw that. Well, it's nice to meet you, Tina. Sorry. Anyway, let's see here. 7 lumbar in dogs and cats. Then there's the 3 sacral vertebrae. Yeah, okay, so the dog's sacrum is different from a cat's sacrum. The cat's sacral vertebrae don't seem to have those foramina in the dorsal. There's the dorsal, which is on the dorsal side, which on an animal is the back, right? You've probably heard of a dorsal fin on a shark. And then there's the pelvic sacral foramina, which are on the ventral side. Caudal vertebrae. Those are, we don't have any caudal vertebrae on here, actually. They're just tail vertebrae. Yep. Hemivertebrae are usually in smaller screw-tailed dog breeds like pugs, Boston Terriers. Yeah, dolphins. Dolphins have dorsal fins. That's true. Man, I wish I could show these pictures, but I just can't because it's not my materials to show. Okay, then there's the ribs. Let's see here. Vertebral joints. Oh, I hope I don't have to. The nucleus pulposus, the slightly eccentric. Wait, oh, it is slightly eccentric, contained under pressure, and prone to escape. Okay, so in the intervertebral discs, there's first of all the annulus fibrosus, which is the encircling bundles of fibrous tissue around the nucleus pulposus, which is like jelly-like stuff that acts as the cushioning. And they sit between the vertebrae. Yeah. There's the nuchal ligament, supraspinous ligament, interspinous ligament, yellow ligament, which is also called the interarcuate ligament. Wow. Okay, supraspinous ligament, intercapital ligament, dorsal longitudinal ligament with synovial bursa, ventral longitudinal ligament. Wow, okay. Then there's IDD, intervertebral disc disease. Happens a lot in dachshunds, beagles, those dogs that are long, you know. We are talking about, well, this is just, these live streams are meant for studying. So, but anyone who wants to learn is welcome to learn along with me. I'm just kind of trying to teach to help bolster my understanding. I'm studying vet school stuff though. This is, right now I'm on anatomy. Intervertebral disc disease. That is when the nucleus pulposus bursts out of the annulus fibrosus, I think is what it was. Yes. The nucleus pulposus bursts out of the annulus fibrosus and it causes pressure on the spinal cord. No, that's not weird. That's kind of cool. Maybe this information will help y'all one day. I especially talk about nutrition a lot for dogs and cats, and nutrition is one of the most important facets of health for a dog or a cat or a human. What you eat is what you are. You literally are what you eat. So if you eat junk food, then you're going to feel like junk. If you eat healthy food, you're going to feel better. You know? Stuff like that. Anyway. What else was I? Okay. Yeah, so again, I wish I could show this picture, but the annulus fibrosis, think of an intervertebral disc. I thought you would say that we are cannibals. No, we're not cannibals. What I'm talking about right now is, okay. So, I'm going to pull this up again. So these are vertebrae, right? We've got cervical vertebrae, 1. This is the atlas, axis. Then we've got 3, 4, 5. Sorry. 6, 7. Right? Oops. Hold on. I dropped it. Okay. Atlas, axis, 3, 4, 5, 6, 7. Those are the cervical vertebrae. Have I ever played Borderlands? Yes, I have. I've played Borderlands 1. I don't remember if I played Borderlands 2, but I did play all the way through Borderlands 1. That was a long time ago, though. That was when it was, like, free for Xbox Live Gold. So, anyway, 7 cervical vertebrae. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 thoracic vertebrae. And then we have 1, 2, 3, 4, 5, 6, 7 lumbar vertebrae. So here's the lumbar. Here's the, well, it's not different anymore. Cervical and thoracic. And then we have the sacral. Yeah, I just looked it up. It doesn't seem to be anything inappropriate. It just seems to be a reference to something. Anyway, where was I? Okay, yeah. And so in between each of these vertebrae, there's an intervertebral disc, right? That's acting as a cushion. The outside of the intervertebral disc, let me just say this is the intervertebral disc. Let's say my hands are the outside. Okay, think about it this way. You've got where'd it go? You've got a water skin, not necessarily this, but okay, let's use this, right? So the water is on the inside and this protective covering is on the outside, right? The metal outside is on the outside. That's kind of how it is in an intervertebral disc, except it's the annulus fibrosus, yes, on the outside, containing the, sorry, I don't want to look at those, the nucleus pulposus, yes, on the inside. The nucleus pulposus is like jelly-like cushioning. It's for cushioning. And then the fiber is to hold it in. And so whenever your vertebrae push against each other, they're cushioned because they're actually pushing on that intervertebral disc. But when the intervertebral disc ruptures, how do you spell which one? Sorry. Cushions, or how do you spell intervertebral disc, or how do you spell nucleus pulposus, or how do you spell annulus fibrosus? I can show you actually. It's going to be backwards though, I think. So, annulus, the jelly is nucleus pulposus. So nucleus, kind of like the nucleus of a cell, which makes sense because it's in the center of the intervertebral disc. Nucleus. And then pulp, like pulp of an orange, pulposus. These are all Latin words. That's why they're, yeah, that's how. I think elements, yeah, elements writing was right. Then we have annulus fibrosus, also Latin. Annulus means ring in Latin. Fibrosus probably just means made of fiber. And nucleus means center, I think. Pulposus probably means made of pulp. I don't know. Do I look like I know Latin? I mean, I know a little bit of Latin. I'm learning Latin on Duolingo, actually, every day. But, or trying to be every day. Anyway. Let's see here. Think of a jelly donut. Okay, yeah, it is backwards. I don't know if there's a way to mirror my stream to make it right side, but anyway. Think of a jelly donut. So these intervertebral discs are basically like jelly donuts in between each of these vertebrae. Think of it like that. Anyway, so intervertebral disc disease is when one of those ruptures, and now instead of having cushion, the bones are rubbing on each other, and that hurts a lot. And that causes the bone to break down. Just not a good thing. Then there's something called spondylosis deformans. Bone spurs. Ooh. That doesn't sound good. Oh, wow. Those are like bone spurs on the bottom of the vertebrae. Those are not supposed to be there. Calcium osteophytes along the bottom, sides, and upper aspects of the vertebrae of the spine. Wow. Okay, moving on to the ribs. I don't have any ribs with me, so you're just gonna have to take my word for it. How did I get these bones? I got them from our anatomy lab. I also have these bones too. These are dog bones. This is a femur. This is the head of the femur, the neck of the femur. They didn't necessarily give them to us to keep, but it's kind of like we checked them out, you know. We'll give them back at the end of the year. See ya, Element. Thanks for watching. But we're gonna give these back at the end of the year, or when we're done with the exam. But this is a femur. This is a tibia. There's also another bone with the tibia called the fibula. Runs right here on the lateral aspect. Wait a minute. I think this is a right tibia. Anyway, and then this is part of the hip bone known as the os coxae. This is one os coxae. But this is the pelvic symphysis where the other hip part is attached. Anyway, I need to get this one anatomy part over with. Ribs. So the ribs have the head of the rib, the tubercle of the rib, there's costal cartilage, and the rib meets the costal cartilage at the costochondral junction, and then there is a costal arch. That's awesome, Tina. Thank you for watching. And see you later. If I'm still streaming, I might be, as long as this is taken. I've got a couple more videos to do anyway, or a couple more streams. I have 3 more after this. Hopefully they don't take too long. Thank you. See you later. Costal arch. The 13th rib is a floating rib and does not articulate with any osseous structures distally. Okay. Hopefully we're getting close to being done here. The epaxial muscles, and then there's the hypaxial muscles. Those are the iliocostalis and longissimus systems. The longus capitis goes all the way to the head region, it looks like. Then there's the longus colli, which is in between, back muscles in between. Hey Cole, how you doing? Vertebra. I am not a doctor yet, but in 4 years I will be a doctor of veterinary medicine. So I'm going to be an animal doctor. But that doesn't mean I don't know anything about human medicine, because humans are animals, right? Okay, so this is kind of just review. Okay, but we are done with anatomy, and so we are done with this live stream. I'm going to make another one though here in a couple minutes or a couple seconds as soon as I end this one. So thank you all for watching. Next time it'll be phys and histo, immunology, and anatomy. So, all right. Thanks for watching. The reason why I'm making multiple live streams is just for me and it's to make these videos shorter, just in case people want to rewatch them, or in case I want to rewatch them to study. Because already it's been going for an hour. That's pretty long. But yeah, I'm going to start another one here in a couple seconds. So thanks for watching, y'all.